Okay, lesson 10D deals with the topic of apportionment. Apportionment refers to dividing something up so that everybody gets their fair share. Since the United States Census is conducted every 10 years, the U.S. Census Bureau counts the population and collects other information. What are some reasons why the government wants this information? Well, it's very important to the federal government that they know a lot of things. One of which is how many people are in each state. Now, you probably know that every state gets 2 senators, but the number of representatives you get in the House, the number of congressmen, depends on how large the state is. That's by population. Large states receive more congressmen, small states have less. So there are states that maybe have 2 representatives, whereas Texas has quite a few representatives. So that's one way. The other thing they want to know is when they give federal dollars and federal grant money. Obviously, larger states need larger grant monies for programs like Medicaid. If your state's very small, you're not going to have as many citizens qualifying for help with their health care. So there's a lot of things where either money or representation are based on populations. In this lesson, we will understand a relative change is different from an absolute change, and we've already done that. In an absolute change, you'll remember you basically just do the final amount minus the beginning amount. That's an absolute change. Did the price increase $20? Did it go down $20? A relative change is a comparison. To get a relative change, we always put that over the beginning amount. And then we can make it a percent if we just multiply that fraction by 100%. So let's go ahead. It says the 2000 and 2010 population counts for the states in the New England region of the United States are given in the table. Calculate the changes in population. So we do final, remember absolute. We're just going to be the final minus the beginning. So 1328, 361 minus 1274, 923. This gives me an absolute change of 53,438. Let's do all the absolute change. So 6547 minus 629. Okay, well, let's not go on. Let's go ahead and do relative change first. To get relative change, we're going to do this absolute change, this final minus beginning, and we're going to divide it by the beginning amount. So I'm going to take this, in this case, the 53,438, and I'm going to divide it by 1,274,923. That was the beginning amount. I'm going to multiply it by 100. I'm going to make it a percent. So 53,438 divided by 1,274,923 times 100. This comes out to 2 places to be an increase of 4.2% because it went up. So let's do this for each one of these. 6547, 629 minus 6349, 097. That's an absolute change of 198,532. And then if I divide it by that original amount, I get a relative change here, and again, this is an increase. It went up 3.1%, 1316,470 minus 1235,786. It's an absolute change of 80,684. Or a relative change of 6.5%. So New Hampshire had a pretty big growth spurt there. 1052567 minus 1048319. That's only a change there of about 4,000 people, 4,248 divided by 1048319. And that is only an increase. It is an increase, but it's only about 0.4%. And then Vermont, which is the littlest one, let's see, 625,741 minus 608,827. That gives me an absolute change of 16,914. Or about 2.8%. Okay, I don't know if we need these on the next page. I'm going to jot them down just in case. What is the overall relative change? Ooh, let's go back. We need some totals. Let's total these up. For this area, the total population to begin with, I'm going to change my color here. Let's get rid of all this for a minute. Okay, let's get totals for these 5 states. 1, 2, 7, 4, 9, 23. Aren't you glad we have calculators to do this? 6, 3, 4, 9, 0, 9, 7 plus 1, 2, 3, 5, 7, 8, 6 plus 1, 0, 4, 8, 3, 1, 9 plus 6, 0, 8, 8, 2, 7. This is going to be 1, 0, 5, 1, 6, 9, 5, 2. Let's put some commas in there. That'll help me read. That's 10 million people. 10,516,000. So 1328361 plus 6547629 plus 1316470 plus 1052567 plus 625741. And that comes out to be 10,870,768. So let's see what that absolute change is. If I do that number minus the 10,516,952, Altogether, we had an increase in population of 353,816 people. Most of that in Massachusetts, because Massachusetts is by far the biggest state. And that gives me a relative change of 3.4%. That seems reasonable. Some states had a bigger change than that, particularly New Hampshire and Maine. The rest had somewhat smaller. So that's an overall reasonable result. So we did our math on the previous page. I'm not going to fill this in, but we can see our absolute was 353,816. Our overall relative change was 3.4%. Which state in the table grew the most? Hint, there could be more than one answer, so explain your reasoning. So let's go back and see, who did we think grew the most? Massachusetts clearly had the most people. They increased by 198,500. So Massachusetts had the greatest increase in population, absolute change. New Hampshire, however, had the greatest relative change. Compared to their size, they grew at the fastest rate. So they only gained a little over 80,000 people, but that was 6.5% compared to the almost 200,000 people which Massachusetts gained. It says each state sends representatives to the U.S. Congress based on its population. Currently, the law mandates a total of 435 representatives. After the 2010 census, Massachusetts actually lost one seat in the House. Can we think why? Well, basically what happens is they have to take 435 representatives and they have to divide them among 50 states. And they do this based on population. Okay. Some states are going to grow very rapidly. Other states are going to grow more slowly. And it's even possible that a few states got smaller, although most of the time that's not the case. Most states are growing. So what happens if when you lose a person, you probably did not grow as fast as the other states. So your fair share of the congressman just went down by one. It's sort of like if you think of a bunch of different classrooms at a college, and maybe some classrooms have 20 students and some have lecture halls and they've got 150 students, and somebody said, we're going to provide materials for each classroom. Well, the classroom that's got 150 students is going to need more materials than the classroom that has 20 students. So these 435 representatives have to be divided up among the 50 states, but they have to be divided in such a way that each state gets their fair share. That's called apportionment. This is the change in the number of representatives by state from 2000 to 2010. Notice Texas was a big winner from 2000 to 2010. We actually gained 4 congressmen. That shows you how fast our state is growing. Florida gained 2. Arizona, Georgia, Nevada, South Carolina, Utah, and Washington actually all gained 1. Now, if you come over here, you can see these are the states that lost representatives. New York lost 2, Ohio lost 2, Illinois, Iowa, Louisiana, Massachusetts, Michigan, Missouri, New Jersey, and Pennsylvania. They've all lost 1. This is a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 seats gained. This better be 12 seats lost. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So they're keeping that fixed number of 435 representatives, but they have to redistribute them based on populations. This has become really contested because of the questions of illegal immigrants. Some states like Texas and Florida and California probably have a higher number of illegal residents. And so there's a question about whether they should be counted or should not be counted. It's certainly in our benefit for Texas to count everybody that resides in the state of Texas, because that will affect not only how many representatives we have, but also how much federal funding we receive for things like schools and healthcare. What do you think happened to the representation of the other states not listed in the table? Those are going to be the states where they got the same number. Most of the time, you don't lose and you don't gain. You just kind of stay and you get your same share. It says most of the states in the loss table actually gained population, but are growing at a slower rate than the states in the gain table. Michigan is the only state that actually lost population during that period, from 9,938,444 in 2000 to 9,833,640 in 2010. Determine the absolute and relative change in Michigan's population. Okay, let's do that. Absolute change is final minus beginning amounts. So in this case, our final 9,833,640 minus 9,938,444. This is going to come out to be negative. It's a loss. 9,833,640 minus 9,938,444. And it's a negative 104,804 people. That's how many people, how much the population went down. The relative takes that absolute amount and compares it to the beginning amount. And then to make it a percentage, we multiply by 100%. So negative 104,804. The beginning amount was 9,938,444. So I'm going to divide that by 9,938,444 times 100. And we can see that that population dropped about 1.1%. If we wanted to write a sentence, we could say something like, from 2000 to 2010, the population of Michigan decreased by 1.1%. This was an actual decline in population of 104,804 people. So I actually wrote two sentences, one about the relative change and one about the absolute change. All right, so now we're going to move on into lesson 11, part A. And let's look at this picture. This looks like it must be a lot. Notice the grid. They tell us that 2 squares is 20 feet and 3 squares is 30 feet. So we can actually measure how large or how small things are. Each little square is 10 feet by 10 feet, or 100 square feet. It says determine 2 things you could figure out about the property based on the scale. Well, we could estimate the square footage of the house. We know that each one of those squares is 100 square feet. It's 10 by 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we think this house square footage is about 2,200 square feet. That's a fairly normal house, a little bit on the large side, not huge. We can see that the lot is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like about 11 and a half. So 11, each one of these is 10. So that's going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and maybe another 5 feet. So maybe about 115 feet this way. And let's count from here. 1, 2, 3, 4, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230, about 235 this way. It's kind of a long, thin lot. Really generous backyard though. So we could say that the lot is 115 feet by 235 feet. We could find some other things, but those were the obvious ones. All right, let's just carry on. It says the Mazurskis are expecting their first child in several months and want to get the backyard fertilized and reseeded before the baby arrives. How does the information you recorded in question 1 relate to the ideas of fertilizing and reseeding? Or what additional information do you need to determine it? Well, they want to get the backyard fertilized. We didn't really look at the size of the backyard, so we would want to figure out the size of the backyard. So let's go back and look at our picture. This backyard, notice it's kind of a little, we're off a little here, so we'll just estimate here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. It's about 140 this way. Down here, you'll notice it's only going to be 130. And this is 115. If we average that 130 and 140, we could say that the backyard is about 135 by 115. All right, we could have done it on this page too. I'm going to write down it was 135 by 115. The Mazurkis decided to begin their improvements with fertilizing and reseeding the backyard. They found an ad for Jerry's Green Team lawn service. Jerry came to their house and said that the job would take about 4 hours and would cost about $600. Okay. Is Jerry's estimate consistent with his advertisement? Well, let's see. We said the yard was about 135 feet by 115 feet. Let's get that yard multiplied out. 135 times 115. It's 15,525 square feet. Okay. 4 pounds per 1,000 square feet at $1.25 per pound. Okay, well, let's stop and think. How much seed are we going to need for this many square feet? If it takes 4 pounds for 1,000 square feet, then it takes X pounds for 15,525. This is a proportion. You always set up proportions where you match the labels. We know this is how big our yard is. We know you need 4 pounds for every 1,000. Now, to solve a proportion, we haven't talked about this, but I think it's something you probably learned in high school. We usually cross multiply. This times this is going to be 1,000x. This times this is 62,100. If we divide that, we get that X is about 62.1 pounds. So it's going to take about 62 pounds of seed. And seed costs $1.25 a pound. So if we multiply this 62.1, or just do 62 pounds, and it's going to cost $1.25 a pound. I see that the cost for the seed is about $77.50. Now, let's do the fertilizer. Fertilizer, let me go back to my blue pen for a minute. Fertilizer, you need 50 pounds for every 12,000 square feet. So we're going to need a little more than 50 pounds. So how much will we need if we have 15,525? So again, we're going to do that cross multiplication you probably learned back in 8th and 9th grade. If I multiply 12,000 times x, I have 12,000x. And then if I multiply 50 times this 15,525, I get 776,250. I need to solve for x, so I'm going to divide by 12,000. And that comes out to roughly it comes out to be like 64.7. We're going to say that that's about 65 pounds because we're rounding things. And it only costs 50 cents a pound, so that's not going to be too bad. Times 50 cents. That's going to add another $32.50. So far materials don't look too bad. $77.50 plus $32.50. The materials are $110. Let's just add all this. So this was about $77.50. This was about $32.50. They said it was going to take 4 hours. So that's 180. When I add all that up, I get $290. What did he say he wanted to charge them? He said it was going to cost $600. He's charging about double that. I don't know if he was going to include the front yard and that's why he's way off, but that's definitely not what he charged. Okay. That's the end of this lesson, so I'll see you in the next one.